Welcome to Biomed Insights, your channel for exploring the incredible world of human biology. Today we're diving into a fascinating topic, neuroplasticity, how our brain changes and adapts throughout life. Imagine your brain as a bustling city. Roads and highways connect different areas, allowing communication and coordination. Now, what if I told you this city is constantly under construction, with new roads being built and old ones being repaired or rerouted? That's neuroplasticity in action. Neuroplasticity is the brain's remarkable ability to reorganize itself by forming new neural connections throughout life. It's like having a personal brain architect ready to remodel your mind in response to new experiences, learning, or even injury. Let's start with developmental plasticity. During childhood, our brains are incredibly malleable. This is when we form the most neural connections. These connections, also called synapses, are the result of learning new things, from taking our first steps to understanding complex concepts. Studies show that a child's brain can form up to 1 million new neural connections every second. This is why early childhood is such a critical period for cognitive development. But it doesn't stop there. Adaptive plasticity comes into play when we acquire new skills as adults. Whether you're learning a new language, picking up a musical instrument, or even mastering a new sport, your brain is busy rewiring itself to accommodate these new abilities. Take the example of learning a new language. This process not only improves communication skills, but also enhances cognitive abilities such as problem solving and multitasking. Studies have shown that bilingual individuals have more gray matter in the areas of the brain associated with language processing and executive control. What about when things go wrong? Say after a stroke or injury? Here's where injury-induced plasticity steps in. The brain can reorganize itself to compensate for lost functions, with other regions taking over the roles of damaged areas. For instance, if the area of the brain responsible for speech is damaged, another part of the brain can adapt to help recover some speech abilities. This is why rehabilitation exercises are so crucial. They stimulate the brain to rewire itself. Even our daily experiences shape our brains. Experience-dependent plasticity means that physical activity, mental exercises, and social interactions all contribute to the structural and functional changes in our brains. Physical exercise, for instance, not only strengthens our muscles but also boosts brain health by increasing the production of neurotrophic factors, which support the growth and survival of neurons. Similarly, engaging in challenging mental activities like puzzles, learning new skills, or even socializing can enhance cognitive functions and prevent age-related decline. Did you know there are critical periods in our development when the brain is especially receptive to learning certain types of information? For example, language acquisition is most effective during early childhood, and sensory experiences shape our neural pathways most profoundly during these periods. These critical periods are windows of opportunity where the brain's plasticity is at its peak, making learning more efficient and impactful. So, how does all this happen? Neuroplasticity involves changes in the strength of connections between neurons, known as synaptic plasticity, the formation of new neurons through neurogenesis, and alterations in the brain's white matter, which affects how brain regions communicate. Synaptic plasticity allows for the strengthening or weakening of synapses, which is essential for learning and memory. Neurogenesis, although more limited in adults, continues in specific brain regions like the hippocampus, which is involved in learning and memory. Want some real-world examples? London taxi drivers have been found to have larger hippocampi due to their extensive navigation skills. This part of the brain is crucial for spatial memory, and the continuous use of these skills leads to structural changes. And musicians? They often have increased gray matter in areas of the brain related to music processing and motor control. Years of practice and learning complex motor skills associated with playing an instrument lead to significant brain changes. In the medical field, understanding neuroplasticity is key to developing therapies for brain injuries and neurological disorders. Techniques such as constraint-induced movement therapy for stroke patients rely on neuroplasticity principles to help the brain recover lost functions. This therapy involves restricting the use of the unaffected limb, forcing the patient to use the affected one, thereby promoting the brain's ability to rewire itself. So, whether you're learning something new or recovering from an injury, remember that your brain is constantly adapting and changing. That's the power of neuroplasticity. Thanks for joining us on this journey into the brain. Don't forget to like, subscribe, and hit the bell icon for more fascinating insights into human biology.